Good afternoon. Last lecture we solved the numerical example on probability theory, and in this lecture we solve another example on the probability theory. That is, consider a bag containing 3 red and 2 white balls, so that the odd are ratio 4 to 6 against drawing the 1 red and 1 white ball from the bag. And we solve this example, we solve the solution of this example. That is, here drawing of two types ball, that is red and white. Therefore the total number of ways to ball from, that is total number ways of drawing two balls from the bag, and is denoted by small n, and small n is the total sample space. And that is, here total ball is 3 red plus 2 white, that is 5, and drawing, that is the total number of way of drawing two types balls, red and white. And therefore uh, we here we denote the total number of sample space is small n, and that is the total sample space is 5 combination 2, and here 5 combination 2 is 5 into 4 divide 2, that is 20 divide 2 equal to 10. And here total number of sample space is 10, and therefore let A denote the event of getting one red and one white ball from the white ball from the bag. That is the number of way drawing one red and one white ball from the bag, and is denoted the favorable event. That is, we denote the favorable event is small n. And here, that is we drawing the one red ball from the 3, and we drawing the one white ball from the 2, that is 3 combination 1 and 2 combination 1 equal to 3 into 2 equal to 6. And therefore the probability of A equal to, that is probability of one event of getting one red and one white ball equal to probability of A equal to m by n. M is the favorable event and divide n is the total number of sample space, and favorable event is 6 and total sample space equal to 10, that is 6 by 10 equal to 6 divide 6 plus 10, that is B divide A plus B. And therefore R against A are the ratio 4 to 6, and we find the probability of this example. Then we have seen the limitation of classical definition of probability. That is, in classical definition, it is assumed that all outcomes of the experiment under the consideration are equally like, and and this is not the case always. For instance, probability of the passing of examination and failing in the examination are not same. In such case, probability of event cannot be calculated using the classical definition. That is, in classical definition, it is assumed that all outcomes are of the experiment unit consideration are equally like, and there is not the case always. For instance, that is the passing in the examination or failing in the examination are not same. Therefore we cannot calculate the classical probability in this way. And sometime n, the total number of possible outcome is infinite, and here also classical definition fails. And third, if the actual value of n is not known, then also probability cannot be computed using the classical definition. And here we have seen the limitation of the